Example 15 says, find the area of a triangle. It says, a riveter uses metal plates that are in the shape of a triangle with a base of 12 centimeters and a height of 6 centimeters. Find the area of the plate. So we're finding the area of a triangle. That's our formula, the area of a triangle. We know that that is 1/2 base times height. We know that 12 is the base. We know that 6 is the height. We know that it's measured in terms of centimeters, and area is always that unit squared, so it's going to be centimeters squared. If you need the picture, again, you don't have to draw the picture, but what we have here is the height of this is 6 centimeters, and the base of this is 12 centimeters. So there's the pictures of it. So we've identified the variables, we've identified the formulas, we've labeled our answer before we've done any math. Now let's start plugging it in. It's going to be 1/2 times the base, which is 12, times the height, which is 6. Plug that into your calculator, 1/2 times 12 times 6. I'm getting 36, and then it's our units squared, so that'd be centimeters squared. We put that answer in the blank. We look on for example 16. It says, find the amount of felt needed to make a banner that is in the shape of a triangle with a base of 18 inches and a height of 9 inches. Okay, so we know that the height is 9, that the base is 18. We know it's a triangle and that we're trying to find the amount of felt needed. So we need the inside of it. We need the area. So we're trying to find the area of a triangle. We know that formula is 1/2 times base times height. Let's label our units. It's measured in terms of inches. This is area, so our units has to be inches squared. Area is always units squared. So let's see. We've labeled our variables. We've labeled our formula. We've labeled our answer without doing any math. Let's plug in the numbers. 1/2 times the base, which is 18, times the height, which is 9. Plug that into your calculator for me. Let's see what you get. I'm getting a total of 81 inches squared. There it is. Let's look at the next shape. The next shape is called a trapezoid. Again, a trapezoid, we have opposite sides, or 2 of the sides are parallel, the other 2 aren't. Okay, that's what makes it a trapezoid. It is a quadrilateral, specific type of quadrilateral. With a trapezoid, they call it 2 bases because it depends which side you flipped it on, right? So they call it base 1 and base 2 for the parallel sides, B1 and B2. And so what is the formula? And I want you to notice the parentheses on this one. It's really, really important you have the parentheses. It's 1/2 times the height times, and then in parentheses you sum the 2 bases. Again, what does this come from? When the 1/2 base B1 plus B2, that comes from finding the average of the 2 bases, and then the height is from the formula of finding the area of a parallelogram. So really what we're doing is the area of a parallelogram with finding the average of the 2 bases. So that's where that formula comes from. Again, I don't care that you know where the formula comes from. I just know that you care that you know the formula and can use the formula. So that's something I'd be putting on my note card. Okay, number 17, it says a boat dock was built in the shape of a trapezoid. So I'm going to draw a trapezoid here with bases measuring 14 feet and 6 feet. And then we have the height of it being 7 feet. Okay, so let me do this. We have 14 feet, I'll call B1. 6 feet, I'll call B2. And then 7 feet, I'm going to call H. And I know I'm trying to find the area of it, and it's a trapezoid, so the area of a trapezoid is 1/2 times the height times, in parentheses, the first base plus the second base. Again, this is area, so my unit is feet, but because it's area, it's going to be feet squared. I've identified my variables, I've written my formula, I've labeled my answer before I've done any math. Now let's plug in the numbers. So this is going to be 1/2. We need to be very specific here. The height was 7. And then in parentheses, we do B1, which was 14, plus B2, which was 6. So here we have 14 plus 6 is 20, divided by 2 is 10, times 7 is 70. Again, please do that in your calculator if you're not good at math in your head. So I'm getting 70, but again, I need to label my answer. This is all measurements in feet, so my answer, because its area, has to be feet squared. Number 18 says, find the area of a patio that has a shape of a trapezoid Again, let me draw that trapezoid again. With a height of 9, bases measuring 12 feet and 20 feet. Okay, my picture's pretty awful, but that's okay. I don't really care. All right, so we know we're finding the area of a trapezoid. The formula for that is 1/2 times the height times the sum of the bases. My units here is in terms of feet, so my answer, because it's area, has to be feet squared. I've identified the variables, I've written the formula, I've labeled my answer. No math done so far. Let's go ahead and plug in the numbers. It's going to be 1/2 times the height, which was 9, times the sum of the bases, which would be 12 plus 20. Plug that into your calculator. Let's see what you get. I'm getting a total of 144. Again, this is my units squared, so that would be feet squared.